Welcome to today's session in the GÉANT training series, Forensics for Sysadmins. After Klaus and Stefan have started off end of last year with this series, I will be taking over now with 2 talks on persistent storage acquisition. Today will be the introduction, more or less. And we'll hopefully cover, we'll be short on time, obviously, but we'll hopefully cover some basic case, the very basic case of how to approach this. And on Thursday, the idea is to go to talk about more difficult and more intricate cases that are not as easy and have even more pitfalls than we will discuss today. So let's get started. So here we go. So the plan for today is get an overview of generally what the idea is, some general remarks on what thoughts you should be having or what considerations you should be giving before joining this endeavor of getting storage, persistent storage, cloned or copied for forensic purposes. Then go over some easy cases, maybe have a demo if time allows, which, well, maybe we'll just skip that if time is short. The easy cases are not as interesting anyways. And then finally go over some things to repeat, some things that can trip you up to watch out for. And finally, if time allows, we'll have hopefully some time for discussion and questions and the like. So, as always, a word of warning: we are not lawyers here at DFN-CERT, or at least the presenters are not. I am certainly not. What we do here and what we tell you here in these courses is by no means legal counseling. So if you have the suspicion that whatever you're about to do in your forensic engagement will lead or might lead to an actual legal action, then stop, get your hands off your keyboard. Don't trust whatever we said, whatever we tell you. Talk to your local lawyers. Laws vary from jurisdiction to jurisdiction, and depending on what you're doing and where you are located, there's the very real possibility that inadvertently, of course, you destroy evidence in the eyes of the court. So whenever you suspect that there's something fishy going on, and this will lead to or might lead to legal repercussions, then please talk to your local lawyers. Hopefully you have one. So, prep, remarks, and introduction. So the big picture here is you want to get your hands on some sort of persistent storage to analyze that. What do we need? What do you need to consider before doing that? So let's see, what is there? What kind of storage are we talking about? What size of storage are we talking about? Where is that storage located? What is the objective of your analysis? So in other words, what do you want to achieve? And how safe do you want to play this out? And we will be talking about all of these points briefly for a slide or two, and then move on to some basic cases. So there's plenty of potential places of persistency here. You have all kinds of storage devices. There's plenty that I've even not going to mention here, and I've not placed on this slide. So that you might hopefully not encounter in your daily life, at least in terms of forensics, because those are way more interesting than these that I present here. But so mostly I expect that US sysadmins will know at least about these kinds of storage systems that I've just randomly selected here off the Wikipedia. So RAID arrays, DAT drives, USB sticks, any kind of flash memory really. Ancient hard drives, hopefully not more modern hard drives, you name it. Persistent storage comes in all ways, shapes, and forms. And just you have to realize what exactly you're talking about before we can consider what what we can do in order to store, or more precisely, in order to acquire this data that is stored on those devices. So mass storage devices usually come with some sort of underlying structure, right? In many cases, you have your mass storage, your physical mass storage device that is partitioned into partitions. And those partitions may, in the case of, for instance, BSD, may be subdivided into slices. There may be logical volumes, there may be RAID volumes, and there may be file systems. There very likely will be file systems in there. There may be virtual images on those mass storage devices. And data can be hidden. Let's rephrase that. Data can be stored, obviously, in any of these layers. And of course, in forensics, you not only care about the data that is obviously stored there, but also about the data that is not so obvious. So you'll find that some of this data is hidden from plain view. Once you start imaging that, and once you start analyzing your that mass storage device, you'll find that there's data that is not as obvious to see. And that may be on purpose by some attacker, maybe just happenstance, maybe just happening to not be as obvious in whatever layer you're looking at. But of course, there's slack space. There's slack space that is usually not accessible from, let's say, higher layers, right? So from the perspective of the file system, you cannot usually look into data that is outside of the, say, partition boundary, or that is unallocated, or even deleted. Deleted files in a file system are usually still there, or at least some of the time. But you cannot, from the point of view of the file system, see them. So you may have unallocated space in volume groups. You may have space between non-aligned partition boundaries for whatever reason. One very popular reason is that these days partitions are created starting with offset 2048 instead of directly after the MBR, as used to be the case when storage was more expensive. So now you have a slack space on pretty much every hard disk drive that has a master boot record or a master partition table, and starts its partition in the modern way, its first partition in the modern way at 2048, because the MBR is only 512 bytes long. So another thing to watch out for that may or may not be of interest to you is metadata. So when you actually acquire, get a disk drive, or say a disk drive, then that disk drive even stores data about itself in hardware that you cannot usually clone by dumping the data it stores. So even with all the imaging I will present here, you will not even get to that data. So for instance, and this is experience from a live case of mine that I've handled, that I've had the pleasure to handle. So there was in this particular case, there was a sysadmin who had a disk drive acquired for his official capacity, but it was doubted whether he actually ever used it or took it home and played with it at home. So eventually somebody, his boss came up to him and inquired about this, and he couldn't find the drive. And a day later, he presented a drive that was of the right capacity and claimed that, whoa, he found it. And he had been using it all along for his official duties. And it was just sitting in the back of the shelf and he couldn't find it. But he had been using it for years. So we were called in and helped analyze this, and we looked at the disk drive. And analyzing this, first thing, well, it was all zeroed out. That was expected. He said that he blanked out the drive, so that was consistent. But looking at the lower metadata that the drive keeps, this drive told us that, oh, look, I've been started only 3 times. So, or 4 times, single digit anyways. So yeah, no, this drive was definitely not in use for years. So something fishy was going on. This was a very interesting bit of information that you would never get if you look at the higher layers only. So wrapping this up, it is always advisable, from my point of view, to get data from a device on as low a layer as possible. So you don't want to get files if you can get. You don't want to get individual files if you can get the entire file system. You don't want to get the entire file system if you can get the partition. You don't want to get the partition if you can get the actual drive, the entire drive. And you don't want to get the entire drive if you can get the physical device. For every layer that you give up, you lose information, potentially at least. That is, well, you lose information, and that information that you lose is potentially interesting to you. So it is advisable to start low, so to speak, and get as complete a copy as you can possibly get. On the other hand, mass storage comes in a huge range of sizes these days. And this is not even due to the devices that we're talking about, but due to the fact that mass storage these days can be spread over many devices. So on one end of the spectrum, you have, say, a USB key or what have you, a floppy drive with 1.4 megabytes, or even older if you're old enough to remember 360 kilobytes. On the other hand of the spectrum, you have multi-petabyte arrays of, say, Lustre file systems or the like, GPFS file systems, GFS file systems, anything that is spread out, or even even in terms of block storage, you can even have network attached storage that will just give you block devices that are petabytes in size. So this, of course, raises at least potential problems when we're dealing with acquiring data. Problem number one is, if we want to acquire the data, how long will that take? Even if you're merely copying stuff, then, well, that is quite possibly prohibitive. So that will quite possibly block your endeavor right there to get as low as possible a layer of data. So you might be forced to select what you get. On the other hand, whatever data you acquire for forensics analysis will also have to be stored somewhere. And that in itself is a problem. So the obvious answer to this would be, well, the obvious approach to this would be, well, you need a target device that stores as much as the source device does, right? So you want to say you want to acquire a hard drive of, let's say, 1 gigabyte. Is it? No, that's not realistic. Of 1 terabyte, whatever, doesn't matter. Of one terabyte. then you need another hard drive of 1 terabyte to store it to. That is not exactly wrong, but it won't do you all that much good, as we'll see. You're likely to need more than the same amount of storage. And in fact, in my opinion, you need at least twice, if not more, for reasons that I'll explain. So that is another aspect of of this game. If you have a problem with, say, a file server, a central file server of a university institute that you'd like to take a look at, then, well, you might not be able to get your hands and copy petabytes of data just for the heck of it. Even if you wanted to, there'd be no time and no place to put the data. So these are very real problems in actuality. The next point, where the storage located that you want to look at. So it is crucial to consider where the data is relative to you, right? Or relative to your lab, if you will. So this can be quite significant, and you can on one hand have the data physically in your hand, or the storage device at least physically in your fist, or it is also quite possible, and that's another thing that I can personally attest to. It is quite possible to happen that you would like to analyze data, do some forensics on a machine that is literally halfway across the world, say in the middle of Africa, as happened to me once. So the actual issue, of course, is not necessarily the geographic distance, but the network distance, so to speak. So you don't really only care about how far away in terms of miles or kilometers the data is, although that does play into the equation. But you also care on how quickly you can get the data if you were to transmit it over the network, right? So in fact, some well-connected university in the middle of Africa may be closer to you topologically than, say, a mountain shed in the middle of the German Alps would be, from my vantage point here in southern Germany. So that is quite possible. Although, of course, bearing in mind that if you really, really want the data, then you can always just go there. Always just go there, meaning, of course, if you have the budget and the time. So it's a two-thing consideration, two-aspect consideration here. Next on the list is you want to consider your objective of analysis. What exactly do you try to achieve? There's a number of things you might want to achieve. So you might just want to, just in quotes, quote, just unquote, find out what happened on whatever machine. You might want to demonstrate and practice that due diligence, so that you do the right thing and you realize that it's good to do the right thing and have a decent look. But that's that then. Or you might want to help or even guide external investigators, say the police. Maybe the police have come and asked you if you can contribute or can help them in any way because they're understaffed. Who knows? Might have happened to somebody on this call. You might want to secure evidence for actual legal action. For instance, if you know for a fact that some crime has been committed and this happened from this machine. This doesn't even have to be, for instance, the usual thing that these days is usually quoted in these things is child sexual abuse material, but it doesn't have to be CSAM, right? It can be more quote unquote benign. For instance, some sysadmin that takes home his work's equipment and plays with it at home for non-duty work. That might be not desired by his boss. So that would then require a different approach. And the more formal your objective is, then the more restricted your options are, because you can't just wing it. If the goal is to find out, to learn something, then you can, well, whatever. If you don't learn something, what's there to lose? But if the goal is that you want to convince a judge on the other end of the spectrum that something in particular happened, then you'd have some more interesting things to do along the way, and you need to make sure that you actually are stringent enough and in your methods, in your methodology, in your approach, that you can actually convince a judge. Usually that won't happen to you. So depending on hopefully that won't happen to you. Depending on what you want to achieve, you might be needing just an evidence bag if you want to play it safe, a tamper-proof or a tamper-evident at least bag that you can put your evidence in. Or you might need some, which is depicted on the top right, or you might need some forensic write blocker, which is generally a good idea if you want to do this game more professionally, which makes sure that whatever you do, it doesn't end up altering any data on the drive. But careful, we already talked about the metadata that the drive itself keeps. So there's interesting stuff here. This is depicted as just a sample on the bottom right. Or you might want to have a small safe in your office where you can put evidence so it doesn't get lost. Or you might want to go to Fort Knox or whatever to real vault. Maybe you have access to some real vault at the university if something is important enough to you. So again, the more formal your objective is, then the more thought you need to put into this, and likely the more effort, and you likely don't want to do that. So related to that is your personal feeling of safety, your personal requirements of safety. So from your point of view, would you be okay with losing data, losing access to, say, accidentally deleting evidence? Depending on what you want to do, again, right? If you just want to find out, then you might be able to live with, oh, okay, I didn't figure it out. If you want to, if your boss desperately wants to have somebody fired, then that might be a different story. If, say, child porn was distributed via your institution, then that might look very bad. If the police subsequently went ahead with press statements and saying that, well, we were investigating, but those dumbasses from that university or from whatever managed to lose the evidence. That might be not what you or anybody else wants. Is it acceptable to change parts of the evidence? Again, not necessarily intentionally, but how safe do you want to play it? How much effort do you want to put into making sure that nothing ever happens to the original evidence? Same story, essentially. You might be good with running up the counter of how many times the disk drive is spun up. Might be okay with you, probably is, if you know that's happening. But you might not be okay with say, file system checks or things of that nature, or installing automatically installed updates or stuff of that nature. And finally, final aspect that I just mentioned here for completeness sake, is it acceptable to you that others unintentionally get access to that data that you just acquired in your capacity as a forensic investigator? Most certainly, this question is here just for completeness, as I just said. Most certainly, you do not want to do that. You do not want to have others unintentionally access data that you acquired in your trusted position as a forensics investigator. So, all things considered, usually anything forensics call for a fairly high level of safety. So you want to play it safe. Usually, it doesn't mean you have to have a safe, but it means that you should take some due diligence in what happens, what doesn't happen. So much for the preparatory remarks. So let's see, how do we approach the data? Of course, the advantage of persistent persistent data storage is that it's persistent. Duh. So it doesn't go away. In other words, you have time. You don't have all the time in the world usually. Somebody else usually wants some results sooner or later. But unlike other things that we have already talked about in this course, things don't go away just because you have a weekend have a break over the weekend. There are actually two exceptions to this, somewhat. One is encryption keys, which are present as long as a system is up and running. If in doubt, those are gone if the system is shut down, unlike persistent storage. And of course, these days, usually well, maybe not usually, but sometimes temporary file systems /TMP and so on will be on RAM disks, and that also gets lost, obviously, which may or may not be interesting to you. Again, if at all possible, go get the device that you want to have physically. If that is not possible, go get a master copy, quote, master copy, unquote, of the data on as low a level as discussed before as possible, and then create a working copy. And obviously work on that working copy. Take your master copy and put it in your safe storage, secure storage, whatever you want to do with it. Don't touch it anymore. Neither touch the physical device nor the golden image or the master copy if you have that. So, how to actually grab the data? As just mentioned, it is generally advisable to get the physical device. That is immensely helpful. I've reiterated that. I hope to really drive home that point. If at all possible, go there, grab the hard drive. In my experience, people are usually rather cooperative if you ask nicely, and it usually helps a lot if you have some, say, form or letter of statement prepared beforehand. That, oh look, I need to take your hard drive, but I'll give you I'll fill in this form saying that I took this hard drive for forensics purposes with this serial number on this date, just so you can show it to your boss, or well, so the guy who you're taking the hard drive from can show that to his boss. That usually helps and goes a long way in my experience. Getting the actual physical hard drive pretty much guarantees that you get all the data there is, right? Because there's nowhere else any data stored. But as we already discussed, this is not always possible because either because it's just too large, you won't be taking out, no matter how many forms you have prepared, you won't be taking home a rack's worth of NAS storage. You won't be taking home anything from 500 kilometers away unless you really mean to. But usually that just won't happen. Or you maybe won't be taking home any physical device because that's just not what the actual owner of the device wants. Because maybe that's too important to the person. Whatever is on there, maybe too important to give you just give you the hardware. All these things happen, and there's more reasons that I've not covered here. That I'm sure you can think of a lot of reasons why you won't be able to get the physical device. The next thing to consider is if you actually get the physical device, you want to make sure that you are able to read it back at home in your lab. Which means make sure that you have the correct controllers, right? There's little things more embarrassing than grabbing a SAS drive from somebody, from a sysadmin, and then having to go back a day later to ask him, oh well, would you mind giving me a controller as well, because I don't have a way to attach SAS storage to my lab machine. you need to have all the correct interfaces. You need to have all the, again, this is important, you need to have all the correct cryptography keys. Klaus has talked about how to acquire memory dumps. On a running system, when crypto devices are mounted so that the crypto volumes are unlocked, then obviously the machine needs to store the actual master key in memory because it accesses that drive. So if you have a memory dump of the running machine with the crypto device attached, then you're good to go. You just need to find it. These are the things that, the kinds of things that you actually need to consider when you take home a drive. The easiest case, and of course, is if somebody gives you a USB stick, right? Then you can take that home and treat it as diligently as you want to. That is, of course, not always the case that things are as easy, but hopefully many times it is. If you cannot get a hold of the physical device, then get a master copy. If you cannot get the device, then you can hopefully get to the device physically. Go there, bring say a USB drive, an external USB drive that is sufficiently large, and bring your favorite boot medium with your favorite set of tools. After making sure that you have all the crypto keys and stuff you need, boot into that, if you can, boot into your boot medium, boot into your tool set, and clone the data onto your mobile storage. And then treat this clone like your original device. And take that back home with you as you would the original device. Now what you do then, back at home, again, create a working copy. Take the original or the master very carefully. We're talking about that, what can trip you up there. Carefully clone the data to create a working copy. And then store the original or master copy safely and securely. Cannot stress this enough. Be very careful when you clone or copy a hard drive. I've seen more cases than I'd like to admit of people accidentally cloning the wrong way. So suddenly your evidence is zeroed out by copying a fresh drive over onto that evidence. I've seen that happen. Also not fun. In the best case, it's embarrassing. In the worst case, there's worse implications. After you have your working copies, store the master copy or the original safely, so that actually you know where it is, can't get busted. Important. That's important. And then work on the working copy. Obviously, if anything goes wrong, then later on you can just go back to the working copy. Go back to the original and create a new working copy of that. You might even want to consider, if it's really, really super important, that you never touch, or that you absolutely minimize the number of times you need to touch the original. You might want to consider having a two-step clone. So once clone the original evidence once, and then create another copy of that, so you can actually lock up the master evidence for good and never ever touch it again, and use that clone as a source for fresh images if the need arises. So we've talked about cloning the data frequently in this talk, without ever going through what that actually means. Generally, of course, this means make a copy bit by bit of the raw data, as raw as you can get. And this can generally be achieved in a number of ways. I've given you 3 here. There are a bazillion other tools. These 3 are just the ones that, very well-known species. So the most easy to use in many ways, the most versatile and almost always available tool, at least if we're talking Unix systems, and in fact, even on Windows systems, some minor updates is cat actually. So that works in many instances. If there's nothing else and you cannot get anything else to work, then cat might do the trick. It'll just take the data from one device and put it somewhere else. Next on the list is DD. I trust everybody knows what DD is. Offers a lot more parameterization, obviously, than cat does. But essentially, it does the same thing. In particular, it cannot at all handle errors. Once it hits a read error, which might very well be the case in your investigations, then you're out the window. It'll just break essentially. So you get everything up to the read error, and then off you go. So what I usually use whenever it's possible or available is DD Rescue. Now, DD Rescue is sort of a rewrite of DD that'll allow for things like skipping over unreadable parts of the input. So say some cylinders of your hard drive are broken and won't deliver any data, but just error messages, then DD Rescue will not fail as DD would or cat would, but it will skip over those parts and just zero it out in the output. So this will get you almost always what you actually in the end want, as much of the image as possible without too much of a hassle. It has sane defaults. So its major drawback is that you cannot pipeline it. You have to actually store it on disk, so to speak, somewhere else. You have to store the output on disk. So you cannot output to standard out, which in certain cases is, well, turns out to be a problem. I've taken down DD Rescue and DD_Rescue here because those are two different programs, different projects that with very similar objectives that you might run across. You might encounter both of these. DD Rescue without the underscore is the GNU version of DD Rescue, which is the, as far as I can tell, the more active and the more advisable to use. Whereas DD_Rescue is the older project, but not quite as actively developed. So people, your mileage may vary. Use whatever you're comfortable with. If you have any other tools that you prefer, by all means, go ahead, use those other tools. All of these tools are available for all the Unix flavors, so macOS, Linux, BSD, and in particular also for Windows. You might have to download those. DD and cat are helpfully included in, say, BusyBox, which is one binary, or if you install, say, Git for Windows, then that's also included as well. DD Rescue usually have to, as far as I'm aware, download and install, but that shouldn't be much of a hassle. Alrighty. Having said that, there's also, just for completeness sake, I'm not a big fan of this. There's also hardware that will clone a drive. Usually, this is just for SATA drives. Really took off since SATA was around. It's just a drive bay, a USB connected drive bay for that you can plug two SATA drives into instead of just one. And usually those double drive bays have a button that says copy now, copy from one disk to another disk. This, of course, means that you will have to have at least the correct size, or the at least as large hard drive in the second slot as in the first slot, obviously, but that's true for other methods of copying as well. And it's really easy to put in to switch the slots inadvertently. So make extra sure. If you use this, be absolutely certain that you put the right hard drive in the right slot. This is in particular, this is the instance that I've seen. I've seen this. This was the first instance I've personally seen where when people actually cloned a brand new hard drive onto an evidence drive. It happens really easy. Having said that, in order to clone the data, many times actually what this comes down to is you need to find the right arguments to put into that DD or DD rescue or whatever command line. And that boils down really to some glorified DD command. And in order to know what block device to access, you need to find out what exactly you're looking for. And there are some tools that help you on a running system to see what block devices are there and how what their properties are. And those are I've given some sources of information here. Just the ones I use usually: block ID, ls block, and the entire dev disk directory tree. There's lots of information there. Disk by ID, by a disk label, by yada yada. You get it. And finally, things that you want to remember when you clone data. Again, I have said this numerous times. I cannot stress this enough. It's really, really easy to copy the wrong way. And this is really, really embarrassing. Make sure that you actually copy from your source to your target, not the other way around. You will all say, oh, well, this will never happen. This is so obvious. No, well, yeah, it is obvious, but it's still, typos do happen. And I speak from bitter experience. Triple check your source and target devices. Make sure the target storage is actually large enough. What I mean by this is not, yeah, you need the same size drive, obviously, at least. But consider that if you have a drive that you want to say maybe store a dump on a file system, then that file system will take up some space as well. And it might not be as obvious, right? So if you want to clone a 2 terabyte drive onto another 2 terabyte drive, you cannot put a file system on there. If you do, and this is the actual nasty thing, if you do put a file system on there, it will not work. It will work up until the file system, the target file system, is full. And that will take hours. That is the nasty thing. You will not find out that you have made a mistake here until you have wasted hours or days cloning this. So make sure that the target storage is large enough upfront. Make sure if you clone into a file rather than directly onto another device, which I generally recommend. I generally recommend cloning into files. That's more versatile than cloning onto another block device. If you do that, make sure that the file system that you want to write into actually supports files that are large enough. For instance, X3 and X2 file systems cannot hold very, very large files. 16, I believe the limit is 2 terabytes or something, which might not be large enough. X4 should be good. XFAT should be good, but obviously FAT16 is not. Verify that the copy is actually accurate, that no copying errors occurred. Shouldn't happen, but it does happen. If possible, run checksums on the fly, which in some cases is possible, in some cases is not. But if it does, it saves you a ton of time. And generally, I recommend very, very much that you set that the first thing you do after cloning data is into a file, at least, is setting that file to read-only. And in particular, setting that file not only to read-only, but also setting the immutable bit, if at all possible. This way, even any admin or root user cannot accidentally delete the file. All right. Looking at the time, I think, well, I trust you will not gain too much from seeing how a DD command line is assembled. So I suggest we skip the demos and wrap up. So to recap, the circumstances generally will dictate a lot of the options that you can or cannot pursue in how to go about acquiring the data. In general, at least in my opinion, it's very advisable to get as much as possible in physical form. So go somewhere, grab a hard drive. That saves you a ton of time, if at all possible. So you want to, if not possible, aim for as low a layer as possible, as in get the entire drive cloned. If you rather than logical block devices, get entire partitions rather than files in the file system. Get all the files rather than individual files, so that you have as much information, or rather that you lose as little information as possible. And obviously, where the source storage is located and what size it is will make a huge difference on what options are available to you. And again, things to be aware of: incomplete copies. I mentioned that if your target storage is just a little bit too small, then you might not even notice that something's missing until you realize it, and that might be too late. In general, insufficient storage is not a good thing to realize when it's too late. You better get stuff up front. The wrong argument order, the wrong mount points, the wrong device names, copy the source to the target, not the other way around. One thing I haven't mentioned yet, but that might fall onto your feet, is when you clone something, when you clone entire partitions, say, then there might be some programs, distributions that try to be helpful and automatically mount stuff for you. That might not be what you want. In particular, that might create problems with replaying journals, updating counters, updating access times, all kinds of stuff that you don't really want to be done unless you really mean it. So beware of that. Just make sure it doesn't happen to you. And finally, to reiterate in this, missing crypto keys. Mentioned this numerous times. So the pictures I've taken from the Wikipedia, here's the URLs, and with that, still on time for a few more minutes for questions. Any questions? Thank you for your attention. If not,
thank you, Toby. That was really interesting. I have a question myself before anybody else starts putting questions in the chat area. If data is in a cloud service provider like AWS or Google or Microsoft, or indeed across all three, you may not even know which country the data is, and the data may be stripped across multiple drives in multiple servers.
Correct.
How do you get that data? Because you don't even know where it is, so you can't even kind of like request the copies.
Yes, that's an excellent example of what I meant by the circumstances may dictate what you can get.
Yeah.
So if you cannot get, or if there is no meaningful way to get the actual physical data, so to speak, then the only course of action left to you is to just use the APIs and get whatever data you can get from there. Maybe you can convince Amazon to get you some lower level storage that they may have access to or may not have access to. Personally, I kind of doubt that they will put much effort into that, but they certainly have a way of getting lower levels. But this touches a good point, which in fact the very same issue, the very same core issue, can easily happen to you if you have your own system at home, your own cloud system at home. If you run a Kubernetes cluster or something, that can happen as well. And then you have the chance to actually dig a bit lower in terms of levels, right?
Yeah.
You can actually log into the storage server and look at whatever stripes are available to you. But it gets complicated really quick.
I mean, one of the interesting services I've seen recently is a service called Qubit. I don't know if you've heard of Qubit, Cubbit,
Yep.
which is basically a kind of crowdsourced peer-to-peer storage system where you have a couple of terabytes in your home and you share
Yep.
stripes of data from in homes across the world, literally.
Yep.
You know, your data is in jurisdictions you don't even know where it is, let alone where it could be. And raiding all of those houses would be, you know, a practical impossibility.
Yes. Yes. Which that raises a legal set of nightmares on its own, but different story. But yes, correct. You are correct.
Any other questions from anybody else? Sorry, I'm hogging the questions there for a second. I can't see any questions coming through at the moment. Okay, so we're coming to the hour. Thank you so much, Toby. Thank you very much, Klaus, Christine, Stefan, and everybody else. I'll be getting this recorded out and shared with everybody very shortly. And thank you so much. And we'll see you again on Thursday.
Thank you. Take care.
Thank you very much.
See you, folks.
Take care.